Alright, this video is going to be on identifying and drawing prisms and pyramids. We're also going to be determining the number of faces, edges, and vertices of a solid figure, and drawing the front, top, and side views of solids by completing an assessment or an assignment with 80% accuracy. There's a lot of key vocabulary in this objective. Prisms, pyramids, faces, edges, and vertices. These are all going to be focuses of this activity. So we're going to start off by just talking about what a solid is. So a solid is a three-dimensional figure that encloses a space. We learned yesterday that a polyhedron is a solid whose faces are all polygons. So a face is your flat surface of a polygon. The edge would be like the lines that connect the faces or on the edges of the faces. And a vertex is a point where three or more edges intersect. You're going to note, I'm going to just put a circle, like a shaded in circle, everywhere there's a vertex on this polyhedron. You can see by kind of darkening those points where the edges connect, in every case the three edges connect together to make that vertex. Those are called a vertex, or the plural would be vertices. Okay, so in this case there are 8 vertices in this polyhedron. All right, and then the faces would be like the parts of a cereal box. If you think about, and I'm going to use an example. So here's a 3D version of this little cereal box here for you. So the faces would be like the front, or the back, or the sides, or the tops of the cereal box, okay? And so you notice I darken the edges black on this particular cereal box, all right? And the faces are like the flat pieces of cardboard, and the edges would be the black lines that connect those pieces of cardboard. You could imagine this as being 6 separate rectangles that will all be glued together to make that box. So we have a pretty good understanding on what prisms are, or solids are. We're going to go ahead and compare. And I know we did this with the actual models yesterday, but we're going to compare kind of the definitions or descriptions of prisms and pyramids. So a prism is a polyhedron that has 2 parallel identical bases. The lateral faces are all parallelograms, and in our cases, our lateral faces will be rectangles, or squares potentially. A pyramid is a polyhedron that has 1 base. The lateral faces are all triangles. So you can kind of see, I can't rotate it like I could yesterday, but you can see in both cases, the shape of the base tells the name of the prism or the pyramid, and we definitely experienced that yesterday. So let's try it right here. We're going to take a look at a prism up here, and you can see that it has 2 bases, okay? These are the 2 bases, all right? And then these are faces, or we typically call them lateral faces. So this, because the bases are rectangles, this would be a rectangular prism. Now, in the second example, again, we're going to note our bases are, there's always going to be 2 congruent bases. And those bases are both triangles, and then these are our lateral faces. And so in both cases, the lateral faces are rectangles. But in this case, the base are triangles. So this makes this a triangular prism. Okay? So the next thing we're going to do is we're going to be counting faces, edges, and vertices. So I've already kind of darkened these and turned them into almost little like ping pong balls on the edges here, or on the vertices here. So you can count 1, 2, 3, 4, 5, 6, 7, 8 vertices. Now remember, the edges are the part that connect the vertices. So you can see there's an edge, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You can see by counting them as I trace them, make this much easier to do. Now, since this is a prism, we know it's going to have 2 congruent bases, and then it's going to have lateral faces that wrap around, but we should realize that the bases are also faces of the box. So if you think back to my corn pops example, I might say that the top of this box and the back, or the front of the box and the back of the box, are my bases. They're congruent. And then each of the sides are my lateral faces, in which case I'd have 2 bases and 4 lateral faces. The problem is somebody could say, well, this is the top, this is the bottom, because they're congruent, those are my bases, and these are my lateral faces. So for that reason, we must consider whichever you chose as your bases and your faces in the case of a rectangular prism, you just got to know that they're all considered faces. So if we go back to my previous example, you'll notice that although I wanted to write faces here, I wrote lateral faces because bases are faces too. So with that said, you can see that we've got our 2 bases and then 4 lateral faces, a small one, a medium one, a small one, and then a large one. And that's a total of 6 faces, 4 lateral faces, and 2 bases. All right, now this is not a standard prism that we would use. This is actually what you would consider a trapezoidal prism because the 2 bases are trapezoids. For our purposes, we won't be doing prisms like that. Just wanted you to kind of experience that, those different shapes of those bases. All right, so here's one that's a little more a format you could anticipate. This is an octagonal prism. Now, again, the number of vertices are very easy to spot. So 1, 2, 3, 4, 5, 6, 7, 8. And then obviously there's also 1, 2, 3, 4, 5, 6, 7, 8 on the bottom, giving me a total of 16 vertices. Now while I'm at it, obviously this is an octagon on the top and an octagon on the bottom. So I know I've got 8 edges on the top, 8 edges on the bottom, and then 8 that connect. You're going to start to notice that with prisms there's a pattern here that there's 3 times as many edges as there are sides on the base. Okay, because you've got your sides on the top, the sides on the bottom, and the sides that connect. And then finally, since we know that it's an octagonal prism or an octagonal prism, we know there's 8 lateral faces plus my 2 bases. So again, we kind of have a pattern we can follow to help us to understand how many there will be. Let's go ahead and practice that pattern, taking a look at this pentagonal prism and seeing that relationship. So again, finding the vertices is easy. I'll go 1, 2, 3, 4, 5. Same on the bottom, 1, 2, 3, 4, 5, giving me a total of 10. See, it's a pentagon prism, so it's going to have twice as many vertices as it does on its base, just like the octagon prism. We said before that there's 3 times the number of edges, so we should expect there to be 15 edges. But we can test that theory. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And the same theory again with our faces. We know we've got the 2 congruent bases that each, and there's 5 lateral faces, giving us a total of 7. So you can really use this strategy, because sometimes it's kind of hard to trace, but use that strategy of understanding those relationships. The next goal I have for today is to be able to draw some prisms. So if you want to draw your own rectangular prism, you're basically going to follow a couple of steps. The first step is you're going to draw 2 identical bases. So I'm going to go ahead and draw them like this. So I got one base and then another base. And you want them to be about the same size if this is going to work well. Now if you really want to make this nice, you'll go ahead and you'll use a ruler. Then you're going to want to connect their corresponding vertices. So this corresponds with that. That's a new vocabulary term. It means it goes with. And so that goes with that. And this is the upper left, so that's going to go to that. This is the lower right, that's going to go to that. And then that's the lower left, that goes to that. Now, typically what you would do is you change any hidden lines to dashed lines. In order for you to see this, I used a marker, so I can't erase my dashed lines. The dashed lines certainly make it a lot easier to kind of see the perspective when you're looking at a picture. But for my purposes, it doesn't matter to me whether they're dashed or solid lines as long as you drew it yourself. So now, a pyramid follows some very similar procedures. But because pyramids only have one base, you don't have that job. you just draw your base. So we'll draw in this example, they started with a triangular base. They drew a point at the top and connected that point to each of the triangle vertices. And then they changed to dashed lines. Now again, I won't be able to do that part, but I certainly can make a rectangular prism. And I'm going to do this by making a rectangular pyramid, a rectangular base, and I'll put a point up in the air, and then I'm going to connect that point to each of my vertices. And that's going to give me a nice triangular pyramid. Okay, and again, with a ruler, it certainly would turn out a lot nicer. So here we go. I'm going to ask you on your own scrap paper. I'm just going to use standard policy of hoping that you're actually going to follow through and do this. I'd like you to pause the video and try to draw your own square prism and then your own pentagonal pyramid. And then after you're done, start the video so you can see how I drew them. See if you did them the same way. All right, assuming that you paused the video and now you've restarted, I'm going to go ahead and draw a square prism. I'm going to start by drawing a square, and then I'm going to draw a second square. It's usually best to not draw them right on top of each other so you can see the perspective a little better. And now I'm going to connect all their corresponding vertices. And there we go, nice square prism. Now remember, it doesn't need to be a cube because square is the base, okay? So there's my two bases and the rest are lateral faces are rectangular. Pentagonal pyramid. Now I know a lot of you might have had some trouble drawing a pentagon, but remember a pentagon doesn't have to be a regular pentagon. It could be any 5 sides. I'll try to draw as close to a regular pentagon as I can. And then I'm going to draw my point up here and I'm going to connect all my vertices to that point. Again, this would be much easier with a ruler. All right, and there we go, pentagonal pyramid. Our next phase will be looking at views of a solid. So here's one of those old school erasers. It kind of looks like a trapezoid if you look at it from the side. And that's exactly what they've drawn. Is the front view, if you look at it from the front facing this way, what you'd see is a trapezoid laying on your desk. If you look at it from this view here, all you'd see is a rectangle. And if you looked at it from the top, think of it like an airplane flying over, it would just see a rectangle, it wouldn't see the whole thing. And our idea of being able to draw views of a solid is it gets us to understand what composes the solid.